So let's continue learning about trees. So I was learning about breath first search yesterday, BFS, and then yeah, I just looked over it. But let's go watch this video
So
about it again,
next,
just to review it, and we can do two problems about it. I think that'll be it for today, and then let's see. Let's go from there. So I'm gonna mute myself. Yeah, just gonna watch the video and learn about BFS. Um, yeah, we'll get back to you in maybe 15 minutes, okay? When I'm actually doing the problem. All right. 102 binary tree level order traversal. Given the root of a binary tree, return the level order traversal of its node's value. Return the level order traversal of its node's value from left to right to level by level. Alright, so in order to do this, what we can do is, so let's first check if we have an, a value. Okay, so it should be if root. So since this is BFS, we will be needing Q to store our data. So yeah. So in DFS, when we're using recursion, we automatically have a stack in the back. So that's basically like a language thing where I think Python has it. I think Java has it too. I mean, that's how he explained in the video. And then if you want to do like iteratively, you have to create your own stack or queue based on your need, correct? Since breadth first search, which is BFS, is FIFO, first in, first out, so we will be needing queue, right? So we can do queue equal to deck. Did I write this correctly? Deck. Give me 1 second. Deck. Alright, that is correct. That is correct. Alright, if we do have a root, then let's q.append the root. Right, let's add that to our queue, which in this case would be 3, right? That is added. And then what we do is we go level by level. So if while while the length of the queue is greater than 0, when it's not 0, that means we have elements in it, right? So we have 3 in it, and now we're gonna have to iterate. So we can also make so that's basically it, and then we can just go about it. So here we would have current, because we have to store the 3 because we're gonna pop it now. What we're gonna do is we're gonna do q dot pop left dot I think that's the syntax for it. So current will be equal to 3, which we are popping, so we popped it off, and right, let me think just in case. Okay, so what do we do next? I'm thinking. So root, we traverse it, we come to the first level, right? We pop it, we save it, but then when we're saving it, we do. Yeah, actually, I can't recall it. By the way, I'm blocking my screen because there's like copyright issue of this website. So, that's what I'm thinking. That's what I was thinking, right? Because if we pop it, then that basically becomes 0, right? And then I can't traverse through this, like I can't add that in. So, so which means, so when there's value in it, where I in range length q, right? We traverse it, there's one node in it, so it only iterates for one time because the length of q is equal to 1. From 0 to 1, 1 is not inclusive. Alright, and then we can store the cur, which will be equal to q dot pop left, right? And if there's left, if cur, okay, now what we're doing next. So we popped it off. We popped off the 3, so it was 3, and now it equals to this nothing in it. So now we're going to check, what does it have a left node, does it have a left side of it, right here, does it have it? If it does, we're going to implement it, we're going to add it to our queue, so it's going to be 9 and 20, right? So it's going to be 9 and 20, right? That's what happens. After that, so basically we're going to have to check if q dot left. If yes, then we do q dot append dot q dot left. Yeah, we add the left side of it, the node, into it. Not q dot left, it's cur dot left. If q dot right, we just do q, not q, what am I doing? Should be cur, and this should be cur, and q dot append cur dot right. That's much better. Okay, so we add those in right here. Alright, we add them in. Now we finished out the loop because it was originally only one. It was only one. The length is only 1, so you only iterate for once. We go through, alright, finished. We go back to the while loop. Now we have 2 thing in it, so now we have 9 and 20, correct? After we have that, we go in here, we check for the the length of the queue, which is 2, and we go in, we save the current, which is 9, right? And we pop the 9, which will be equal to, let's do it here now. We go into 9, now we pop the 9, which will be equal to 20. We check if 9 has a left or right child. Okay, it doesn't, so we go back to 20, correct? So nothing gets added. So we run this loop again. Because it has 2 originally. It was 2 because the length of the queue was equal to 2, and now we come to 20. And we pop 20, right? But we check if 20 has a left or right. It does. So now it becomes 15 and 7, right? And we come back again. We do the loop. We check right here. Okay, does it have any? No, it doesn't. Alright, finished, right? So we can just do here cube, correct? And I think that's basically it. This nothing. So deck is now valid by record. Well, we can do this. We can do result and correct. We can just return the result. Will this work now? Whoa. Oh. We have to append the value of cur, because cur itself is a node, correct? All right. So let me see what I'm doing right now. My output only gave me this. The expected output is this. Alright, so in order to do that, so I'm only appending this thing, which in that case. So I think it should be before popping it. Let's of course, it's not there. how do I append the entire, let me see here. What if I just do this? So yeah, I need this. With root, we come here, right? Let's delete this as well. And I climb here, so kern only has the value of the first node in the left. So right here, we can do errors. Let me pick up a phone call. My bad. Yeah, there was a phone call. My bad. Let's get back to work. Okay, so I was thinking about this question. Still don't know how I can solve it. You know, we pretty much solved it. We're going roads by roads. I know that for sure, but okay, so what I don't get is that how is it only printing oh, I did a crucial mistake right here, I think. Yes, look, I did a mistake. So if there's left, we append it. If there's right, we append it. It's not like if it's not this, then this. It's not like that. Right? I mean, I spot the error. That's good. That's one good thing. Right, let's get started. So right here, what's happening is that 9 and 2 and 15 and 7 should be on the same line. But I don't know how we can do that. Right? So how can we do that? So right now what's happening is that we're always appending the root of the first node of the list, right? What we're trying to do is whenever we add a new one, we have to add that in also as in group. Right here, 3, 9, 10, and 15. It should be 3. There's 1, gone. 9, 20, gone. 15, 7. How can we do that? Can I do that by adding these in? But how is that gonna work? Is it not possible to just so I add this, right? What if I don't add it? Root. How much longer am I going to stare at this screen? So we went here, we first add right here. Okay, what if I just do this, right? We take this off. Here we do result.append root.value, so it gets the first, right here. We do result. We've got to add parentheses, brackets here. And here we do result append dot curve dot left dot value. and curve dot right dot right. Ooh. Ooh. I thought this is going to work, so we did current q dot pop not left. We pop to left, and we're gonna do. Yeah, I think I have to check. For in range length q current equal to q dot pop left. So only in this loop that I can add it to the current node. What I can do is result dot append is this possible? I'll just be trying anything at this point. Oh. Yeah, I think I'm not understanding one of the properties well. I think that is my issue, but let's look at the editorial. Yeah, I didn't figure it out.
So next, let's talk about.
So, give me a second. Let me pull out the. Let me pull it out. Ooh. Okay. Alright. I am checking the solution right now, and I am understanding where the problem is. Upload. Okay, so I'm back. So I checked out the solution, right? And of course, like BFS solution. So we were close to finish it, but of course I didn't get this part, which we could have done it by, we created a queue, our queue. Okay, we have like an array to append whatever. So if root, then if there's root, then we add the head node into our result. So for example, like this, right? The 3 is here, the head node would be here. So that's where we did this. So we got these part correct. We even got like this part correct also, but we just didn't know how to add it to the result, right? I think that the reason why I failed, I mean not, yeah, failed at doing it is because of didn't understand array properties, or I don't know how to rune, how to code around. I don't know why I didn't get it, but so we can just do a temporary level stack, right? So if there is a kern dot left, we can just append that into level. So it'll have a new subarray that contains this and this, and we can append it to the big one, which is the result. Append the current dot left value, right? Same thing here, level dot append cur dot right dot val. So like that. After that, after the thing is finished running this part of it, and we create a new one, a new empty one, so on and so on. So right here we should append the level that we created, which is a new one, right? And before it gets sets to 0, before it gets wiped out, the arrays, we should add it to the result. So we only add it if it's null here, then it's not going to be added, right? So which means we're going to have level either way. So when the length of level is not equal to 0, then we add it. So if it's equal to 0, then we don't. We can, in Python, this is pretty easy to implement. We can just do level, which means there is something in level. Then we can just do result dot append dot level, right? Then we can run it. Oh, what am I doing? Right. Yeah, now it's correct now. Alright, we're done with this now. I do want to check out like another solution where he did it with DFS. So I'm gonna have to close my monitor again. Sorry about that. But let's continue. Let me just check it out how he did it. So this was, of course, DFS. You know what, actually, Let me just watch his video. I mean, the code looks pretty confusing. Like, I'm getting lost in it, but I do understand the code. Like 80% of it, but I think it's just better to just take a look at his video. So in his solution video, he does not talk about the DFS solution. So I'm gonna run it in my head myself. And just give me a moment so then I can, take the code here. Alright, so forgot to turn this on. So we got a result here, right, that we're appending. We have our depth first search. So depth first search meaning that we're going into the depth first, right? Let me document our simulation. So depth, first we do 0, yeah, and then gonna be the root, right? And first we check if it's not a root, then we return none, but that's not the case, right? So we do have the root, and the length of the result is equal to depth. Yes, it is. So result, we don't have anything yet, so it is equal to 0, equal to depth, and we do result, append an empty subarray, empty list in it. So it's going to be look like this after here. And now we're checking result.depth, which is the zeros index of this. We append. Göç korkturamsız.
Yok, güç korkturma bir tamak kılaydı.
Benim tabaklarınız mı?
Siz tamam mı? Ne mi desiniz kıptırma? Kavu koşan, bana sevmeyse. Lamen? Mifen?
Mifen buldu ha.
Mifen, prem?
Göç. Bir kanlı bir göçünü korusunuz masma.
Abi güçlü ilk programda sanki.
Hep koyduk ko. Kalı göç bağı o. Mesela özünüz bilip benim. Ben çıkıp sevmek miyim yok çıkıp. Ben çıkıp korugan sevmek miyim yok kapıyım bat diyorsun.
Ama güçlü abi ip koysam bunu kapıyı masajının bana.
O kalı güçlü kıyıvırın ha.
Okşumaydı.
O okşaydı o men ya bir men göç bolsun diye. Mesela özünüz bilememiz. Bak işkimleyip mi? Right, if length result equal to depth, right, then we do this. So here we're just appending. So right, result to depth, which is equal to 0, then we're just appending the top value, which is equal to 3. And then we come here, we run the DFS, we go to the left side of the root, right? Depth plus 1. So now the depth is equal to 1, and we're here. it is a root, it is a node, so we don't return none. Length of the result is equal to depth. So then we, yeah, it is equal to 1 now, and it is equal to then this, we just add this in. So I guess this is always equals, right? And the result at depth is equal to node.value, which is equal to 9, right? And we go here again. We go there. I mean, there's nothing there, so I guess we're going back. So we go to the left side of this, right? It's not a node, so we return none. We go back up, we come here, it's not a node, so. And then we go up, we go down here. I'm getting so confused by this. It doesn't look too hard though. Maybe there's a YouTube video explanation that I can look up. Okay, let's search up. Actually, I want to see this video. Alright, I decided to, leave this video out for a little bit. So let's not think about that. Let's go on to the next question, okay? Give me a second. Alright, binary tree right side view. Given the root of a binary tree, imagine yourself standing on the right side of it. Given the root of a binary tree, imagine you're standing on the right side of it. Return the values of the node you can see, ordered from top to bottom. Okay. So that means we're going to do 1, then 3, then 2, then 4, then 5. Oh no, we're only returning the... I see. So since we're watching from here, we can see, these ones. Okay. That's interesting. That's interesting. Seems like we're gonna have a result, which we're gonna append it into. That's a good question. I think that's a very good question. Go and think now. Let me give myself 40 minutes on this. Going to find it in 40 minutes. I will. Okay, so that's what I think, right? Very similar to the last question, actually. Yeah, so what I can do is that no, I don't want to write. I don't think I need to write it down. Let's see. So I'm gonna create a queue, which is like right. If root then queue let append dot root, right? And result plan root value. Alright, this is gone. So now we have the first element of the so we have this right now, right? Now while length of q is greater than 0, what do we do? If it's greater than 0, we do for I dot q, right? You see right here, you know what you see what I did. So if there's level, if the we appended right, and we see that it's something gets added on it. So let's say we got this one, right? So we added 2, we add 3, so now level has 2 and 3, right? So we always get the last node of it. So let's say if it has these two, then that means the last node, which is -1, will be the 3 one, right? So we add that into our result. In this example, we added in, so we do, the level dot last node, which is 4, we add that into our result. And for in this example, I mean, we already have these, right? We already have this, and we just go on it, and here we add the last one, which is 3. This one, only 4 gets added, so we're just gonna, the -1 is still gonna equal to 4, -5 is still gonna be equal to that. Yes, so that's basically it. Let's see if I actually did it correctly. I didn't talk much because, I was just trying to focus on the code, passed all the test cases. Let's run it. Boom. Yo, that's pretty satisfying. That's really satisfying, actually. That's nice. I mean, it was a really good question. Yeah, I mean, the solution of the last question really helped me. I mean, yeah, like, very similar question. But also a fun question, though. That's like the visualization. I like it. I like how they put these arrows on it. It's like easy to understand what they're talking about. Most of the time, my problem is that I misunderstand what the question is saying, and I just be doing like wrong thing for complete, 30-40 minutes. Got it in 10 minutes. That's pretty good, I think. All right. So let me let me blur this. Let's see what else is left here. Right, done this. Okay. So I'm done with breadth first search, BFS, BST and BST sets and maps. That's the next question. I didn't check out other solutions for this binary right side view, right? Let me just take a look at it, just in case what it's saying. So, I'm really getting confused about the DFS solution about it. It's just hard for me to get my head around the recursion. Probably because I'm not used to it yet, but so this can be shortened, I think this way.
Well,